One's a sine, one's a cosine. What do? We have options. What does your brain think? After what you just did on the quiz, even though some of you got stuck, you saw me, I tried a way which was quite creative, and sadly it went a wrong direction. But coming back, what would your brain think? Divide by cosine squared or change sine squared to 1 minus cosine squared? 1 minus? Okay, using a Pythagorean property. So I can change this to 1 minus cosine squared equals 3 cosine squared. Couldn't I get the cosine squareds together by addition? 1 equals 4 cosine squared. Then couldn't I say 1/4 plus or minus square root would equal cosine? Doesn't that mean cosine equals plus or minus? Isn't the square root of 1, 1 and 4, 2? All solutions, I'm thinking plus 2 pi n, but I just need all the different places. Cosine is 1/2, and if you haven't been a cheater chart believer until now, 1, 2, 3, nope, that's sine. 3, 2, 1, 1. All the pi over 3's. Yay! So x must equal this pi over 3, and that pi over 3, and that pi over 3, and that pi over 3. All of them plus 2 pi n? Am I wrong? No. But, goodness gracious, that's tedious. Is there a better way? There is. All of this can be summarized in x equals pi over 3 plus pi n and 2 pi over 3 plus pi n. Another way of looking at it, you could also say that this is x equals plus or minus pi over 3 plus pi n. Well, how are all of these the exact same thing? Think about your unit circle. Aren't we looking for this guy and that guy and that guy and that guy? So one way is to say, hey, all 4 plus their coterminals. You're right. Because plus or minus says any quadrant's fair game. The other way is to say, okay, this guy, pi over 3, plus pi n. That doesn't go all the way around. That goes where? That gets the first and third quadrants. First and third quadrants, check. This one would get the second and fourth quadrants. Just going a semicircle away. But how does this one work? Well, this one says, oh, you can go up pi over 3 and the third quadrant, or you can go down pi over 3. So all of these end up with all 4 locations and all their coterminals. Which one looks nicer? I'd say that one. But is that one and that one also correct? Are they correct? Yeah. Yeah. But what was the key? Changing sine squared to 1 minus cosine squared. The other way, if you had divided by cosine squared, would have been tangent squared, which meant tangent would have equaled plus or minus square root of 3. Square root of 3 over 3, 1 square root of 3. Oh, also at pi over 3. Both ways would have worked. Oh. Uh-oh. Uh-oh. Nope, it's a cosine of 2x. We could distribute it, but do you remember yesterday how I said don't be scared of factors equal to 0? Yeah. Oh! Let's just set each one equal to 0. We end up with cosine 2x can be 0, or can you guys do enough mental math to get the negative 1/2 on your own? Minus 1 divided by 2. When does this happen? Well, we actually, I think, talked about this one yesterday, and it ended up cosine being negative in the second and third quadrants, and 1/2 is 3, 2, 1 at pi over 3. So that one's going to be at 2 pi over 3, and 4, oh, I can't go 4 pi over 3. Can I go negative 2 pi over 3? And that gets me in the second and third quadrants. Sorry, I should be up a little higher. But, because I'm only looking for those angles, not all the coterminals. But what about that guy? Cosine needs to be 0. Don't worry about the 2x right now. Cosine needs to be 0. Oh, let's think about inverse. We can think about inverse, which asks the question, when is cosine 0? Well, cosine 0 at pi over 2, and 3 pi over 2, and 5 pi over 2, and negative pi over 2, and negative 3 pi over 2, and wait, why am I putting so many? You're only supposed to be looking, wait, what do we still have to do to get to x? And guess what happens when we divide everybody by 2? What once was too big now becomes just right. Wait, 5 pi over 4, isn't that too big? 5/4, that's bigger than 1. Okay, well, forget those guys. Pi over 4 and negative 3 pi over 4. What do we have? 2 groups of answers. How do we get there? Oh, factors equal to 0. We're not scared of. That little 2x, some of you might want to grab a quick little baby highlighter and be like, oh, hey, this is weird. When it shows up in homework, I better look back at this example, how we have to divide by 2 at the end. So we have to include more angles than you would think of. It's a little bit of a weird concept. But this one, not factors. What do you think we better do just to make it possible? I think we better maybe get a common denominator after changing cosecant. And then uh-oh, there's a division, guys. What do we do? Get rid of it by multiplying. Okay, we don't have to worry about that guy. But we do still have to worry about this guy. Oh, that's going to be impossible because that's... Wait. Can I square root a negative?
No. Undefined.
Guess what? Oh, but pause. If it had been a positive, guess what the square root of 1/2 is? Square root of 2 over 2. It would have been at pi over 4. All right, kiddos, go check out this homework. See how you do. I'll check out number 3 a normal way and not my crazy creative way. And see how it went. Maybe there was a typo and it was impossible. That would be fun. Because then you guys might get 100 even without proving it.